Hi everyone, welcome back. We just finished section 1.4, which means that we are done with chapter 1 of X and on algebra. Today we're going to be doing some review problems together, but I do want to get started with a warm-up and go over the warm-up from last time. In our warm-up from last time, we were asked to identify 3 properties. In the first problem, all that happens is that the parentheses move. The numbers stay in the same order, 3, 8, 1. So because we're not changing the order and we're just moving parentheses, this is the associative property. In the second problem, we have 9 times 1/9, which is the reciprocal of 9, and this gives us 1. This is our multiplicative inverse property. Finally, in problem C, we have 4 plus 7x equals 7x plus 4. This involves changing the order of the numbers. So here we do have the commutative property. Here's your warm-up for today. Go ahead and pause the video right here and take a moment to simplify the expression and submit your answer. Okay, let's get into some review problems. As I go through these, you are more than welcome, even encouraged, to pause the video and try the problems on your own before I explain them. Otherwise, you're welcome to just follow along and get some good review in. Let's start off our review by talking a little bit about inverses. So this question asks us, what's the additive inverse of -5? This has to be something that we add to -5 to get 0. So the additive inverse is going to be the opposite of -5. So that's going to be 5. The multiplicative inverse of -5 is going to be something that we multiply by -5 to get 1. So if you remember, our other word for the multiplicative inverse was the reciprocal. So the reciprocal of -5 is -1/5. The additive inverse of 1/3 is the opposite of 1/3, so that's going to be -1/3. And the multiplicative inverse will be the reciprocal, and that's going to be 3/1, or just 3. Let's take a look at this question. This one has us graph inequalities on number lines. So if you remember, this was where we had our different number sets. Here we're looking at integers and real numbers. So on the left, part A, we're being asked x is less than or equal to 2. So that tells me I have to have 2 somewhere near the middle. So maybe I'll put it right there. Fill in the rest of my numbers. 1, 0, -1. And x has to be less than or equal to. And let's take note that we're in the integers. So x can only be whole numbers and their opposites. So I can be 2, so I'm going to fill in a circle right there. And I can be anything less than or equal to 2. And since I'm in integers here, I have to only put dots. I can't shade in the entire number line. Over here on the right, I have real numbers. So here's where I can have fractions, decimals, anything in between. So again, I'm going to put -5 somewhere near the middle. -4, 3, -2, fill in the rest of these. And I notice that I can't be equal to -5. So I'm going to put an empty circle right there. And x can be anything greater, and I am going to shade in this time because I can be all of those decimals and fractions, all the way to the arrow. Time for a wellness break. Get up and run 2 laps around your house. Let's evaluate some expressions. So we are told evaluate the following expressions when x equals 5 and y equals 1.5. So in this first one, I'm going to rewrite this expression with everything I know filled in. So that's going to be 3 times 5 minus 2 times 1.5. And following PEMDAS, I have to do my multiplication first. So I'm going to do 3 times 5 is 15, minus 2 times 1.5 is 3. And then I can do my subtraction, and I have 15 minus 3 equals 12. Over here, I have x, so that's going to be 5 minus 4 times 1.5. So this is 5 minus, I'm going to do my multiplication. 4 times 1.5 is 6, so I have 5 minus 6, which is going to land me in the negatives. So my answer to this one is -1. Always good to double check these after you do them. Maybe do a few more problems and then come back and try these again, just to make sure we didn't make any mistakes. All right, let's simplify some expressions here. So I'm starting with A, 5k plus m minus 3k plus 4m. I'm going to underline all of my like terms here. And remember, I like to underline the operation that comes with them, comes right before, so that I know what to do with those. So all of my terms here I'm underlining. Let's start with the k's. So I have 5k minus 3k will give me 2k. And I have positive m. I like to think of the first operation here as just meaning positive or negative. So positive 1m, I can kind of fill in an invisible 1 there, plus 4m. So that's going to give me 5m. And I always ask myself, what do I put in the middle here? Well, it depends on whether 5m is positive or negative. In this case, I'm starting with positive 1, adding 4, so this is going to be positive. So my final answer is 2k plus 5m. Moving on to B, I have some distribution I need to do here first. So I am going to distribute this 2, and I'm going to get 6x plus 2y. And I can't forget about this guy over here, minus 6y. Now I can underline my like terms. I have x, I have some y's, plus 2y minus 6y. So my 6x has to stay the same, and I have positive 2y minus 6y, which is going to get me negative 4y. So my final answer is 6x minus 4y. Down here, I have 9a plus 4 times 1 minus a, another one where we have to kind of distribute. So I'm going to distribute first. I'm going to keep the 9a at the beginning. I'm going to add 4 times 1 is 4, minus 4 times a is 4a. Now I can underline 9a minus 4a, and I have plus 4. 9a minus 4a is 5a plus 4. That's my final answer. All right. Last questions here. So let's say I have a rectangle here, and I have one of my dimensions is 3 centimeters, the other one is 8 centimeters plus x. So I have to write an expression representing the area, and I have to use the distributive property. So usually my area is length times width. So I'm going to write my length might be, so my length is 3, and I'm going to say my width is 8 plus x. So here my distributive property is going to end up distributing that 3 to the 8 and the x. So this is a good enough expression for my area. In part B, let's say x equals 1.5 centimeters. Use your expression to find the area. So I'm going to plug this in. I'm going to have 3 times 8 plus 1.5, and I'm going to use the distributive property to distribute this 3 to both of these numbers. So 3 times 8 is 24, plus 3 times 1.5 is 4.5. So 24 plus 4.5 is 28.5, and I have an area, so I have to have centimeters squared as my units. Thank you for joining me, everyone. This was a great review session. We won't be having our quiz until after spring break, but you don't need to study a whole bunch over spring break. We're going to study a little bit when we return so that we're ready to go for the quiz. All right, thank you, and I will see you next time.